All right, today we're diving deep, really deep, into the microscopic world. We're talking about a massive global health challenge, the fight against protozoal infections. This is a battle, waged with some seriously powerful drugs against the world's tiniest, but also deadliest parasites.
I mean, think about it. What if the biggest threats to humanity were totally invisible? It's a pretty chilling thought, right? But for millions of people, it's not a what if. It's their reality. The villains in this story aren't some monster you can see coming. Nope. They're single-celled organisms just wreaking havoc inside the human body. So let's get a look at these invisible invaders.
Okay, so who exactly are we up against? These are the invisible invaders. Protozoa. So, protozoa. These aren't your everyday bacteria or viruses. They're way more complex. Think of them less like simple germs and more like tiny single-celled animals. And when they go into parasite mode, they set up shop inside a host, like you or me, and that's where all the trouble begins. So the big question is, how do they even get in?
Well, it turns out these invaders have two main superhighways into our bodies. First up, you've got the insect bite. Think of a mosquito or a fly acting like a microscopic flying syringe, delivering nasty stuff like malaria or leishmaniasis right into your system. The second route is through ingestion or contact. So we're talking about contaminated food, water, you name it. That's how you end up with infections like amoebiasis and giardiasis.
All right, now let's zoom in on the big one, the most notorious of all of these diseases, malaria. It's really the heavyweight champion of protozoal infections, and it makes for a perfect and pretty scary case study.
See, malaria isn't just one thing. It's actually caused by a few different species of the Plasmodium protozoa. You've got Plasmodium falciparum, that's public enemy number 1. It is by far the most dangerous. But check out that last one on the list, Plasmodium ovale. This one points to a terrifying new problem in this whole fight. The mosquito that carries it is actually developing resistance to our insecticides. I mean, that makes our job exponentially harder.
So what does a malaria infection actually do to you? Well, it's this brutal two-pronged attack. The parasite gets in there and just starts destroying our red blood cells, the very cells we need to carry oxygen around our body. At the exact same time, it's creating a toxic environment in the liver. It's this 1-2 punch that causes those classic, absolutely devastating symptoms of the disease. Okay, so when you're facing a foe this formidable, you need a seriously sophisticated defense. So now let's turn to our side of the story. It's time to look at our medical arsenal, the incredibly powerful antiprotozoal drugs we have engineered to fight back. Now, treating malaria isn't just about killing the parasite wherever you find it. No, it's a strategic 3-stage military campaign. First, you prevent. These are your prophylactic drugs, acting like a shield to block the parasite from ever getting a foothold. Second, you attack. You go after the active parasites that are already multiplying inside the body. And third, you contain the infection. You have to eliminate the specific forms of the parasite that another mosquito could pick up, effectively breaking the chain of transmission and stopping the spread. And here are some of the key weapons in that arsenal. This whole fight really started with quinine. That was the original game changer, a true historical breakthrough. And today, that arsenal has grown to include this whole range of agents you see here. And having this variety is absolutely crucial because it lets doctors tailor the attack plan for the specific parasite and, of course, for the patient. But the fight, of course, doesn't stop with malaria. There are so many other protozoal invaders out there, and each one needs its own specific counter-strategy. For example, those infections you can get from contaminated water, like amoebiasis and giardiasis, they're often treated with metronidazole. But for insect-borne diseases like leishmaniasis, you need a totally different weapon, something like pentamidine. And then you have these hyper-targeted drugs, like benzonidazole, which is used specifically for Chagas disease in kids. It really is like a specialized battlefield. Every single enemy requires a unique weapon. Now, speaking of metronidazole, I have to stop here for a second because there is one warning that absolutely cannot be overstated. You see the quote on the screen, and there's a reason it has all those exclamation points. Do not mix with ETOH.
Now, ETOH, that's just the chemical name for ethyl alcohol, the kind of alcohol you find in beer, wine, liquor. If you mix the two, it can cause a severe, incredibly dangerous reaction. This is a critical, potentially life-saving piece of information for anyone who's ever prescribed this very common drug. Seriously.
And all of this brings us to a really important reality check about our fight against these protozoa. This isn't some battle we've already won and can move on from. No, this is an evolving struggle, filled with constant and very serious challenges.
You know, these life-saving drugs, they come with their own set of dangers. They can cause some pretty serious side effects. Everything from neurological issues to changes in your vision. They can create toxic, dangerous combinations if you mix them with other medications. And they're just not safe for everybody. We're talking about people with liver disease or alcoholism, or for women who are pregnant. But looming over all of that is the biggest challenge of all: resistance. The parasites themselves and the insects that carry them are constantly evolving, literally learning how to survive our best weapons.
So that leaves us with this one absolutely critical question. We are locked in a literal evolutionary arms race with these invisible invaders. As they adapt, we have to innovate, and we have to do it faster. Developing new drugs, new strategies. It's not just some scientific challenge. This is a matter of global health security. Because for now, this battle is far from over.